Hello everyone, myself Ganesh Chaudhary. I am the student of MIT UV. I am here to discuss about slope stability and its techniques. Now, why to understand slopes? Before that, we have to know what is slope. Slope is a inclined ground surface, either can be natural or man-made. Why to understand slope? That is failure of natural slopes and man-made slopes has resulted in much death and destructions. As a civil engineer point of view, we are expected to check the stability of slopes and safety of natural slopes. Failure triggering mechanism means reasons behind that slope failures, which are intense rainfalls, water level change, uh, volcanic eruptions, earthquake shaking, and humans. Now, the causes of slope failure are different. We will see one by one. First one is erosion. The wind and flowing water causes erosion of top surface of slope and makes the slope steep and failure of slope occurs. Second is steady seepage. In steady seepage, the pore water pressure decreases the shear strength. Next is sudden drawdown. Due to sudden drawdown, the shear stresses are more due to saturated unit weight, while the shearing resistance decreases due to poor water pressure. Next is rainfall. Um, Due to long period of rainfalls, water may enter into cracks and may loosen the soil, and slope failure occurs. Along with that, there are also another causes of slope failure, which are first one is earthquake. They induce dynamic shear forces. Along with that, there are lateral forces which leads to slope failure. Next is external loading. Due to additional loads placed on the top of the slope, increases gravitational force, and that may cause the slope to fail. Another one is construction activities at the toe of the slope. At the toe of the slope, we know at the excavation at the bottom of the toe leads to steep slope, and which increases gravitational force and leads to slope failure. Now, there are different types of failure. Broadly, slope failures are classified into three types. As first is face, which we can say also say as slope failure. Second is toe failure, and third one is base failure. Let's see one by one. First one is face failure. Generally, this type of failure occurs when the slope angle is very large. Also, this type of failure occurs where the soil above the toe contains weak stratum. Next failure is toe failure. In this failure, surface passes through the toe. Generally, this occurs when the slope is very steep and contains homogeneous mass. And next is base failure. In this case, failure surface passes below the toe, and this is the worst case of failure of slopes. If the base fails, whole slope may gets to fail. Now, there are some preventive measures to be carried out for stability of slopes. These are categorized by slope stabilization methods and techniques, construction techniques of slope stabilization, and stabilizing strategies to reduce slopes. Let's see one by one. The first is geometrical technique. It contains the flattening of the slope. Second is eliminating part of the soil or rock. Third is eliminating load from the top of the slope. It reduces the shear stresses on critical planes. Another is constructing pressure bumps. By by providing pressure bumps, we are providing extra safety against toppling failure. Second is hydrological techniques. Slope stabilization using hydrological techniques can be achieved by installing surface and subsurface drain pipes and therefore reducing pore water pressure. Second is use of inverted filters, and third one is use of thermal techniques. Use of thermal techniques. This can be done by ground freezing and heating methods. Also, there are some chemical and mechanical techniques for soil stabilizations. First is grouting to increase shear resistance of slopes. Second is construction of gabion structures, baby tree walls, embankment piles for provide resistance against toppling failure. Constructing lime and cement columns. Installing ground anchors, rock bolts, root piles for to provide effective tension to rock blocks. And soil erosion can be reduced by planting shrubs and grasses. There are some stability strategies to reduce slope failure. These are categorized into three groups. First is reinforcement support, second is rock removal, and third is protection. In reinforcement support, it involves strengthening of metal by providing external elements. It includes rock bolts, providing of dowels, tied back walls, shotcrete, and grouting. In rock bolts means providing of rock bolts perpendicular to the joints of rocks Due to this, discontinuity of joints in rock masses are happens. Second is dowels. Uh, Dowels are also known as steel rods. Steel rods are installed in rock mass and then grouted. In shortcrete, shortcrete is in shortcrete is done in soil mass by providing some external steel rods. And last one is grouting. Grouting is the method of injecting a fluid by pressure. Due to this, air and water voids are removed. From this, I have concluded that every time while the construction of slope, we have to determine the stability of slope. Along with that, we know the failure of slope leads to human health damage and other things are damaged. Due to this determination of the methods for stability of slopes are very much important. Thank you.